Cthulhu Faten and happy holidays once again, hackers. Alhazred here, back again today for another foray into the dark arts. As you can see, I don't have my typical surroundings or setup here. I am filming this from my parents' house where I'm spending the holiday season. That's why I'm suddenly surrounded by plants. That's why I'm sitting down. And that's why it's also possible you may hear the screeches of demon parrots, but hopefully not. Even if I do not have my typical mic or camera or backdrop, I still have eldritch wisdom to share with you. And today, we are tackling day 21 of TryHackMe's Advent of Cyber 2022 event. Have yourself a merry little webcam. As the name suggests, we're going to be hacking a webcam today in a very brief but exhilarating introduction into IoT hacking. Now, first, what do we actually mean by IoT? IoT stands for Internet of Things, and it's kind of one of those cybersecurity buzzwords that gets bandied about so much that it somewhat loses its meaning. Generally, though, when people say IoT, they're referring to the increasing number of devices in everyday life that have computers in them, particularly those that are IP-enabled and connected to a network, such as your home Wi-Fi. These devices might seem insignificant, but they fill increasingly important areas of our lives, such as squeezing our juice.
What is this?
It's a juicero.
And it's an emergent and increasingly important discipline in cybersecurity to assess the vulnerability and risk surrounding these devices. After all, without them, how would we play Doom on our refrigerators? Now, you might find this module just a little bit scary, because we're going to kind of pull the curtain back and show you how easy it can be to hack a webcam. But realistically, understand you probably don't need to worry about this kind of thing with your own cameras. You need to worry about the backdoors that the NSA and China have put into the devices themselves. But that's a discussion for another time. There's a lot of reading for this challenge, and I'm going to encourage you to go through it, even though it is a little dry and technical, because it's going to explain the specific protocol we're going to be dealing with today, called MQTT, in more detail. MQTT stands for Message Queuing Telemetry Transport, and it's a simple and lightweight protocol that's commonly used by these IoT devices, although it is just one of many such protocols that these devices may use. This one is popular because, again, it is simple, and it's easy to get it running on limited hardware, which is what many of these IoT devices are working with. You guys know me by now. I'm not about to just sit here and regurgitate the reading material with you and start talking about the publish and subscribe model. Let's head back into our highly advanced and state-of-the-art concept visualization software, and let's get started. Let's hack a webcam. So here we are again in Microsoft Paint. Many of you will recognize this from one of my previous videos for Advent of Cyber this year, specifically Day 9, which was on pivoting. Last time in the Riley and Johnny and MS Paint saga, we discussed our crush, the apple of our eye, our one and only, Riley. Riley makes a lot of videos online, and we love him, but she has no idea who we are, and we cannot communicate with her directly. Fortunately, we have our friend here, Johnny, who goes to her school and is willing to talk with her for us on our behalf and persuade her to speak to us so that we can start working our magic. Recall in that scenario that this analogy was used to describe a situation in which we want to compromise the host, represented by Riley, who's on a different network from us, goes to a different school. And that was represented by this line down the middle. And Johnny, being in that network and also communicating with us, was used to pivot through to reach Riley. Keep in mind that that's not quite the same scenario we're dealing with here. We are on the same network. Everyone here is on the same network. We all go to the same school. The difference here is, in our analogy, we are simply too shy to talk to Riley directly. Riley's one of the popular kids, and we just can't get up the courage to talk to her directly. But we still have our bro here, Johnny, who's going to help us out, okay? There is no pivoting happening here, because what we're going to be doing at a high level is the same. I'm going to be using a similar analogy to represent it and explain it to you. There's also a fourth factor here that we haven't introduced yet. We're going to be expanding the Riley and Johnny cinematic universe by introducing Ron. Okay. We will label him. If you're wondering why we're using this weird font here, that's just the one that Microsoft picked by default. So we should trust Microsoft's decisions with font choices. So Ron is now introduced, okay? We're doing the origin story of Ron. Ron doesn't have much of what you might call a personality, okay? But he does have an absolutely massive, monstrously large number of TryHackMe points. Like, seriously, it's a distractingly huge number. The guy's like O'Day up in here, tip top of the leaderboards. Riley's extremely impressed, and she sends him special videos that we don't get to see. And we're going to represent this. Ron talks with Riley. Riley talks with Ron. That one's pink, but we don't care. Okay, Riley and Ron communicate. But we're obviously not satisfied with this scenario. We want to impress her and get her to show us those videos instead. She and Johnny, fortunately, communicate regularly. Okay? They're friends. Right? Riley and Johnny communicate regularly, and Johnny's our bro. He's our Prometheus, kindling the flames of romance. He's our Poseidon, god of the Broshan, of love. If we ask him in the right way, he will relay our messages to Riley. Thusly, he will relay our messages to Riley, and then if we manage to impress Riley, such as with our Xbox gamer score, presumably, she will send us some of those scintillating videos instead of Ron. Right? So that's what we're going to be doing here, but let's apply that to the MQTT publish-subscribe model. Okay? Riley is the webcam. She's sending the webcam stream to Ron, which is some other legitimate endpoint where the video is being watched, recorded, whatever. Johnny is acting as the broker in this exchange, if you did the reading. Riley is publishing to and subscribed to a number of topics on Johnny, and if we modify one of those topics, the next time Riley checks it, she will get a new message that hopefully, if it's worded correctly and our gamer score is high enough, will get her to send her stream to us rather than to Ron. Right? But how are we going to do all this in practice, and what should our message look like? Let's dive right into the practical details and finally get Riley to notice us. Real yeah awaits, my friends. Okay, so I kind of just skipped past the rigmarole of starting the machine and then starting the attack box and all that. It's day 21. I'm going to assume that you know how to do all of that by now. You can use the attack box or your own machine as always. I'm going to be using the attack box for this demonstration. So here we go. The IP address of my target machine is 10.10.252.121. And we see we do have connectivity with it. So we can start by, we need to figure out what port MQTT is listening on. Now, we can just do a simple Google search. We could do an Nmap scan for all ports if we really wanted to, like this, 10.10.252.121. But that's going to take a long time to scan all 65,535 TCP ports, when we could just Google mosquito default port and find out that the default port appears to be 1883. So let's start there, okay, before we start scanning a million ports. TACP 1883, see what's going on there. And we do see that port 1883 is open on the target, and Nmap is identifying it as MQTT, which is a little bit misleading because Nmap, by default, is not doing any kind of service discovery or anything like that. All it sees is that 1883 is open on the TCP side, and it knows based on its own database that the most common service using that port is MQTT. If we want to do service enumeration, we have to add tech SV. So we'll go ahead and do that. So the TAC SV option is going to determine, first of all, what service is actually running. And second of all, Nmap is going to attempt to discover the version for us, which helps us in a variety of ways. So we have Mosquito version 1.6.9. Fantastic. Looks like we found MQTT listening. Now, we can now see if any of Nmap's default enumeration scripts can help us enumerate this port a little further. The default scripts are invoked with the TAC SC option. Nmap has a huge amount of enumeration scripts for every service you can think of. The default scripts are the ones that are least invasive and easiest to do. And let's see if Nmap will get any additional information for us. There we go. We do get something. And keep in mind that what we're talking to here is Johnny in our analogy, right? We're talking to the broker, okay? We're talking to, if we look back at our analogy here, we are talking to Johnny in this situation. Johnny is the broker, okay? I don't know when I made this smaller, but there we go. We're talking to Johnny here. We're not talking to Riley directly. We cannot, MQTT doesn't involve speaking to Riley directly. We have to talk to Johnny to talk to Riley. Riley is talking to Johnny, we're talking to Johnny. So Johnny is who we are talking to. Hopefully that makes sense. So we're back here and we see that there are a number of topics that are available on this broker. Most of them are related to the broker itself, but we do get one interesting one called device/init, which appears to have some kind of serial number or ID or something like that. Keep this in mind for later because we're going to be using this. But if you wanted to query that topic directly, you can do that with the mosquito_sub tool by specifying the host, our Johnny, 10.10.252.121, which is our target machine. And then the topic is going to be device init as Nmap has enumerated. So we're going to subscribe to the topic and we're going to wait for a bit and we should get some information back. And we do get that ID once again. And Mosquito is going to query that topic every so often to see if it gets updated. So you'll see this getting printed to the screen over and over again as long as you let it run. So we can just Control-C because we found it already. So we know what ID, make sure you mark down this ID. You're going to need it in a little bit. Now, going back to our analogy, we want to talk to Johnny and tell him what to tell Riley. Okay, so we need two things. We need the topic that we need to publish to on this broker that Riley is going to check. We need to perk Riley's interest, if you will. Okay, and you might ask, how can we figure that out? Well, we're going to get to that here in just a second, because the other thing we need is we need exactly what to say. We need a topic and we need a message. And we can find out both of those things in a number of ways, and it's in the reading if you want to go through it. But one of the many ways, or some of the many ways, are through reverse engineering or source code analysis. In this case, we've been provided the source code of the device, so we can review the source code. I've opened it up in Visual Studio to make it a little bit easier for you to see. Okay, you get nice syntax highlighting and all of this stuff. So this is the source code. It's just a snippet of the source code of the device. We don't have all of the source code. Notably, if you look through this, you're not going to see the actual topic. That's been left out of the source code snippet that we've been given. But the topic is in the reading. That could also be discovered by source code analysis as well. It's just not in the snippet we've been given. So the topic they want us to query is device, or publish to, excuse me, ID. That's the device ID that you just enumerated is going to go here. And then CMD. Very simple. All right, very simple right there. Now we have to figure out what message we want to send. We want to publish under this topic. What message do we want to send to Riley? Ideally, this is going to be some message that changes Riley's behavior in some way. In this case, it's going to change the location she's sending the stream to, a place controlled by us. So let's go back to Visual Studio and let's take a look. Well, We see that it's receiving a message. It's saving the topic of the message in this, but we don't see what topic it's actually looking for. We see some things it's printing to the screen. And then we see that it's replacing braces in the payload with nothing. It's just removing braces. And then it's splitting the payload by commas. And then it's doing some more processing down here. And then it's splitting the payload again by colons. Now, the more experienced among you might begin to recognize the hallmarks of JavaScript object notation, otherwise known as JSON. This device appears to be doing some simple parsing of JSON formatted data. So we're not going to get into the specifics of exactly what JSON is or what it's typically used for, but it's a pretty common way to format messages of this nature. So let's open up Visual Studio. We have Visual Studio open already. Let's open up Notepad again. Let's start building out our message. We're just going to build our message up little by little. We see it started with braces, and we see it splitting by commas and then by colons. So we know that there are commas and colons in there. And JSON typically looks something like this. JSON is a series of keys and values, like key 1, colon, value 1. And then that's all for that. And then another key and value. So key 2, value 2. And you could do this infinitely, like with key 3 or whatever. In this case, we're only concerned about two particular keys and two particular values. This is what JSON typically looks like, and strings in JSON will be denoted with the double quotes, right? So let's figure out exactly what keys and values it's looking for in order to change the URL at which Riley is going to be sending her stream. The webcam. When I say Riley, I mean the webcam. Riley is the webcam, all right? So let's go back to Visual Studio. And we see, all right, so we see target CMD equals 10. Very interesting. We see CMD names and values. These are just indices, indexes. Don't worry too much about these just yet. This code might be a little bit daunting to you. I'm just trying to parse it in as simple a way as possible and guide you into how I'm figuring out what it does pretty quickly. So we see that the command payload appears to be command equals 0, URL equals 1, command payload equals payload CMD. So the first key and value is going to be the CMD, and the second is going to be the URL. Remember in Python that indexes start at 0, not 1. So if you see an index of 1, that is the second index, because the first one is 0, okay? So we see that it looks like there's going to be two sets of keys and values, like I mentioned earlier. The CMD name, there's going to be a CMD name and then a CMD value and then a URL name and a URL value. So let's go back to here. So CMD name, CMD value, URL name, URL value. Perfect. Again, we're just filling it in little by little. We're trying to figure out what message that we should send to Riley, okay? In order to change where she is sending her stream. So let's go back to Visual Studio and let's see what else we can glean from this code. So we see CMD if command, it's doing a series of if statements here. If command payload, CMD name, command payload is the first key and value set, that is to say. If CMD name dot lower equals CMD. So it's checking to see if CMD underscore name is CMD. So we go back to Notepad and let's change this to CMD. Okay, cool. We filled in the first value. And then it's doing another nested if statement and it's saying, hey, if the value is equal to target CMD. Now, what's target CMD? Well, Visual Studio Code is highlighting it up here. It's saying 10. It's looking for a target CMD of 10. Presumably there are a number of commands that you could send. But we're interested in this one. So, we can replace this one with 10. Perfect. Hopefully that makes sense. Now we come back over here, and we see, we print command value match. All right, and then it's saying if URL payload URL name equals URL. So another if statement. So it's checking to see if URL name equals the string URL. Now keep in mind, caps don't actually matter between any of these. Like between CMD, you could put CMD in all caps or any case you want, because the .lower method is being used here to basically just make it lowercase and correct for any case discrepancies. Let's go back to Paint. URL, it's looking for URL name equal URL. Perfect. Print RTS PS URL match. And then it's gonna print out the URL value to the screen. And then it's gonna try and send something to send the stream to our URL. So this URL value should be the URL that we're listening on, that we are listening on, that we want Riley to send the stream to. But what value do we want to put in there? Well, we need to set up a listener for Riley to talk to that knows how to parse streaming video, right? So a very, very simple way of doing this is by simply using Docker. Now, don't get wrapped around the axle about what Docker is. Why did it make my... Man, if you open a new... All right, so we got that figured out. So we're going to use Docker to make this a little bit simpler for us. We're just going to run a very simple RTSP server. What is RTSP? RTSP stands for Real-Time Streaming Protocol. Okay, so this is a very simple protocol for streaming video. And we can use Docker to... Basically, we're going to use Docker to set up a listener for Riley to talk to. So we can use Docker run, rm, because we want Docker to not save this container, just delete it once we're done with it. This is a one-time run container. it, because we want to open up a sudo tty and see the output and interact with it. And then network equals host. This is going to tell the Docker container to use the same network interfaces that our host is using. So it'll make our networking a little bit easier. It'll be as if our host was listening instead of a Docker container. And then we're going to use this particular image for a container. Simple server. Okay, so we'll run that. Now it's going to take a second to run. Docker is going to have to download the image, and then it'll start the server for us. Now there's a lot of numbers being thrown at you here. The most important one is this one right here. Just ignore all these other numbers. That'll just confuse you. Just remember this port 8554. And now Docker is listening, or the RTSP simple server is listening for us, for Riley to connect back to it. Perfect. So the URL we're going to be sending is going to be to this. This is the URL. We need a URL to identify this. So the way we're going to identify that is going back here. We're going to we start with the protocol, RTSP://, and then the IP address, which in our case is going to be the IP address of our attack machine. In this case, they put the attack machine's IP right here in the host name. So 10.10.105.163. If you're on your own local VM, you're going to want to use your ton0 interface for this. So 10.10.105.163. 10.10.105.163. Perfect. And then :8554. Remember that this is the port that RTSP is listening on the TCP side, that is. So that's the port you're going to want. And then you're going to want any arbitrary path. You can put literally anything here. I'm going to put Cthulhu fun just because I like those words. The funny words are funny. So, but you can put literally anything here for your path as long as you remember what it is, because you're going to need to know it later. So there you go. That's all it is. That's the whole message. Very simple. We have CMD URL, and then the CMD is set to 10, and then the URL is set to the RTSP simple server that's listening. Okay? Let's go ahead and copy this. I don't think I'm going to easily be able to copy this into my... I'll just copy it into my notes over on the side. Okay, copy that into my notes. And then we will come back over to Firefox, go back over into our other tab, and now we'll use Mosquito again, but this time pub for publish. And the host we're going to use is our target broker we've been using this whole time, 10.10.252.121. The topic, TAC-T, is going to be device / and then remember this ID. This wasn't in the source code, at least not the source code that we were shown, but this is the device ID they would like us to use. And then CMD. So that's the device, that's the topic, I mean, that it wants us to use. And then TAC-M for message. The message is going to be what we just came up with. Now, I'm going to put it in triple quotes. That'll make it a little bit easier. This seems to be the best way to get it to work from my experimentation. Put it in triple quotes because quotes are being used inside of the JSON. So CMD 10, comma, colon, URL, not colon, quotes, URL, and then our URL, RTSP, colon, / 10.10.105.163, colon, 8554. And then the path that you chose. In this case, it was Cthulhu fhtagn. Okay? So now we're going to send that. All right? So you shouldn't get any output. That's good. That's good. That means it's sent without error. And now we can go back over here. And looky here, my friends. We notice that we have a connection from our target. Riley has connected back to us and is now publishing to Path Cthulhu fhtagn with streaming video. Spectacular! So how can we now see these scorching hot videos that Riley is sending us? Well, we can use VLC to load an RTSP path. So RTSP 127.001 colon 8554, same TCP connection, and then the path, in which case Cthulhu fhtagn was the one that I chose. And then VLC should open up just fine for us here. And look at that, my friends.
Oh, that's hot. That's hot.
Oh man, that's the hottest video I've ever seen with snow in it. And we do see we get a flag, TryHackMe, open braces, and in all caps, UR_camera_is_mine. Perfect. We've done it, my friends. Now, we just need to go back to the Advent of Cyber page and fill in all of the appropriate answers here. So what port is Mosquito running on? If we remember, that was 1883. Is the device init topic enumerated by Nmap during a service scan of all ports? Yes and no. I would consider a service scan just the TAC SV, in which case the answer to this would be no. But what the answer they're looking for here is yes. But remember that in order to get Nmap to enumerate the topics on the broker, you had to use the default scripts option, the TAC S capital C option. What Mosquito version is the device running? It is 1.6.9, if you remember right from our Nmap scan. And then what flag is obtained from viewing the RTSP stream? That was TryHackMe braces your_camera_is_mine. And that's it. We've hacked a webcam. Congratulations, my friends. And that's all I have for this video in the final days of Advent of Cyber 2022. IoT hacking is especially esoteric, eldritch magic, and we only ever so gingerly and shallowly dipped our tips into it today. But I hope, as always, that I was able to break it down for you in a way that helped you to understand those higher level concepts, which is the most important part of all of these challenges. As always, if you have questions, throw them in the comments below. You can also reach out to me on Twitter or Discord. I'm always happy to help a hacker out. If you enjoyed this video, check out the others I did for Advent of Cyber this year, or better yet, check out my stream on twitch.tv where I'm slinging memes 3 times per week, mauling over all manner of hacker challenges. Regardless, have a very good holiday season, whatever you happen to be celebrating. Finish Advent of Cyber strong, and keep hacking and adding wrinkles to your brains in the new year and beyond. Cthulhu fun.